There are only 3 more exercises left in this section, so let's complete them. The next one is number 12. Here a function f is given with domain x and codomain y, and which is an invertible function. We have to show that the inverse of its inverse, that means the inverse of f inverse, is the function f itself, that is, this equation is true. And the solution is pretty easy. We first note what we already know. We know that f inverse composite f is the identity function on the set x, and f composite f inverse is the identity function on the set y. And that is why, by the very definition of invertible functions, f inverse is itself invertible and has f as its inverse. That's it. Next we have number 13, which is a multiple choice question. A function f is given with both domain and codomain equal to the set of real numbers. And this is the rule defining the function f of x equals the cube root of 3 minus x cube. Then we have to figure out what f composite f is. Is it x to the power 1 over 3, that means the cube root of x, or x cube, or x, or 3 minus x cube? So in the solution, we just straight away calculate the composite function. We take any real number x and calculate f composite f of x, which by definition is f of x. So let us first put this f of x carefully. It's the cube root of 3 minus x cube. Now we have to calculate the f value of that. So you see the structure of this formula: 3 minus the cube of the input to the power 1 divided by 3. And the input itself is this. So this is how we have our thing. Now first of all, this cube root and cube cancel out, leaving us with 3 minus of 3 minus x cube. And outside we already have a cube root. And you can see that here, after cancelling 3 and minus 3, you will be left with x cube inside the cube root, because minus of minus is plus. And then after finally cancelling the cube and cube root, you get x. So the correct option is C. And finally we have number 14, where we have this function f whose domain is the set of real numbers from which this rational number minus 4 divided by 3 has been removed. And the codomain is the set of real numbers. And the formula defining f is this: 4x divided by 3x plus 4. You can see at once why this number has been removed, because if x equals this number, then the denominator becomes 0, and we do not want that. So that way it had to be removed. At every other real number x, this ratio is a unique real number. So the function is well defined. And it turns out that f has an inverse, which is this map g from the range of f. Actually, it's not exactly okay to say that f has an inverse, but rather that other map has an inverse whose domain is this and whose range is the range of f, and the formula is equal to this. That's not exactly the same as this function, but we understand what the authors wanted to say. So that function has an inverse, which is this g, whose domain will be equal to the range of f, and whose codomain will be equal to the domain of f. But what is that function? These are the options. G of y, is g of y equal to 3y divided by 3 minus 4y, or is it 4y divided by 4 minus 3y, or 4y divided by 3 minus 4y, or 3y divided by 4 minus 3y? And I will just give you this hint, not a full solution. This hint actually has everything. You take any y from the range of f and you calculate this, f of 4y divided by 4 minus 3y. You will see that you are getting y. And based on this hint, now you draw the conclusion. Which one of these options is true?